This is a solution to the second problem in section 7.7. Here we're trying to use the midpoint approximation for an integral using 6 subintervals. And the biggest challenge here is going to be just to get the original picture drawn so that we're correct about which coordinates we're evaluating these things at. Because we're going to have a lot of, I can already see that we're going to have sixths and twelfths and all kinds of fractions running around. So let me first start by putting a picture of the graph of the region cut into 6 slices as described here. So we can see that each of the rectangle widths is going to be 1/6. So we know that the delta x is 1/6. So that's the width of each rectangle. And so I'll be multiplying that by the height of each rectangle. Now the heights are going to be at the midpoint of each of these 6 smaller subintervals. So let me replace this picture with a picture that has those points and the tops of the rectangles drawn. Okay, so here's what the rectangles are going to look like. I've taken those 6 strips and I've drawn a dot in the center on the curve at the center of each strip, and then I've drawn the height of the rectangle across through that dot. So now what I need to figure out, I know each of those dots will have a y-coordinate that comes from f of something, but I want to make sure I'm putting the right somethings in here. So we know this point right here is 2 1/6. It's 1/6 of a unit over from 2. And so I was going to write that as a fraction. That's 13/6. That'll just be easier to think about because each one's 1/6. So that means if that one is 13/6, then the next one is 14/6, 15/6, 16/6, and so on. So so that's an easy way to write them down. It's easier than the decimals, certainly. But that's not the x-coordinate where I'm taking the reading, where my points are. My point's actually halfway in between 2 and 13/6. And so that's actually at 2 1/12 of all things. So this is 13, nope, not 13, sorry, looking. So this is 25/12. Will be the x-coordinate of this first point. So that point will be 25/12 comma f of 25/12. So not the easiest numbers to work with for sure. Now the next dot over is just 1/6 more than that. So the dots really are 1/6 apart. So once we have the first one labeled, we can just work our way over by adding a 6 and a 6 and a 6 for each of the dots. And 1/6 is the same as 2/12. And so we start to be able to see a pattern to the dots. So 25/12 plus 2/12 is 27/12. And I'm not concerned about simplifying this as I go because it's the f of things that really matter here. The x-coordinates don't really matter. The x-coordinates just tell you what to plug in to get the y-coordinate. And so on. So the next one is 29/12, then 31/12, then 33/12, and 35/12. Anyway, so then the rectangle, so my M6 approximation is going to be the width times the height of the first rectangle. And then it'll be the width times the height of the next one and so on. Since that width, that delta x is the same every time, I can use the fact that at the end I could factor that out. So rather than do 1/6 times each one individually, I can just do 1/6 times the whole sum. And the 6th one, what did I say it was going to be 35/12. So there's will be 6 numbers that are added together here, one for each height of the rectangle, and then that's the sum of those is multiplied by 1/6. So that's it. Make sure your calculator is on radians mode, and then when you plug these in, make sure you're careful about how you do it. So for example, the first number, f of 25/12, f of 25/12 is the sine of pi over 3 times 25/12 with the calculator on radians. So that is quite a mess to have to put into a calculator. But one at a time, you can calculate those values. Anyway, so when you do that, I got, for this particular one, if you want to try this one to compare it, my computer went to sleep. I got, for my M6 approximation, I got 0.47807. I forgot how many decimal places it wanted, either 4 or 6, I forgot. Anyway, so that's what I got for the M6 approximation. Don't forget that you can look up websites that have little calculators for these things if you want to check your answer. I certainly won't make you even do 6 subintervals on a test, but you should feel like you can do the ones that are 3 or 4 subintervals without any problem by paper and pencil and calculator. That's it.